Hello everyone, my name is Rakshita Vishwanath Giri. I am a third year computer science engineering student from Sri Siddheshwar Women's College of Engineering, roll number 346. Today we are going to learn about the types of machine learning, which is one of the most important topics in artificial intelligence and data science. Introduction: what is machine learning? So, machine learning is making computer learn from data, improves performance without being explicitly programmed. Machine learning or ML is a subset of artificial intelligence where we train computers to learn from data without being explicitly programmed. For example, imagine teaching a child to recognize fruits. You show them different fruits with the names. Slowly, they learn to recognize apples or mangoes just by observing features like color or their shape. So, machine learning works in a similar way. Based on the how a model learns from data, machine learning is divided into four types. First one is supervised learning, second one unsupervised learning, third one semi supervised learning, and last but not the least reinforcement learning. Let's understand each one in detail. So first one is the supervised learning. It learns from labeled data. Each input has a known output and the goal is to predict output for new data. For example, suppose we want to teach a model to identify whether an email is spam or not spam. We feed it a lot of emails along with their labels, spam or not spam. The model learns patterns and predicts for new emails. And the goal is to learn a function that maps input to outputs, which is nothing but supervised learning. That machine learns using labeled data, and that means each input has a correct output. So examples of supervised learning is spam email detection and predicting house prices, and common algorithm we used is linear regression for continuous output, logistic regression for binary classification, and decision trees. KNN. KNN is nothing but K nearest neighbor, and SVM is support vector machines, while last is neural networks. And these are used in the medical diagnosis or sentimental analysis and also weather forecasting. So, second one is unsupervised learning. In unsupervised learning, we use unlabeled data. That is data without answers, and the model tries to learn the structure of the data on its own. So, for example, suppose we have a list of customer and their behavior, how much they spend, how often they shop, etc. We want to group them into segments like high spenders or low spenders. For example, without knowing the group labels beforehand. So goal is to find patterns, group or structure in the data, and it finds hidden patterns and structures. So, examples of unsupervised learning is customer segmentation, which is nothing but the grouping customer by their behavior, and market basket analysis is nothing but finding products that are frequently bought together. And the common algorithm are used like k-means clustering, PCA for reducing dimensionality, and association rule learning, which is used in the market basket analysis. And this unsupervised learning is used in the recommendation systems and social network analysis. So next one is semi supervised learning. So it is a mix of a few labeled and many unlabeled data, cost effective and improves accuracy. For example, image classification and medical diagnosis. Labeling data is often time consuming and expensive. That's where semi supervised learning comes in. This type of uses a small amount of labeled data and a large amount of unlabeled data. For example, consider a folder of 10,000 images where only 500 are labeled. For example, cat or dog. There are pictures of cat or dog. Instead of labeling all 10,000, we can train the model with the 500, and remaining 9,500 will learn the patterns. To improve learning accuracy and using a combination of a labeled and unlabeled data. So, example of semi supervised learning is speech recognition, image classification, medical image analysis, and the common techniques are self training and co training, and it is used in the natural language processing NLP, or language translation, document classification. So last but not the least, it's reinforcement learning. Learns by interacting with the environment, receives reward or penalty for actions. Goal is maximize long term rewards. This is an exciting type of a learning based on feedback and trial and error. In reinforcement learning, the model is called as an agent, and it interacts with the environment. For every action, the agent receives a reward, or we can say penalty, and it learns to take better actions over time. So the next slide is all about the concepts and use case of the reinforcement learning, where key terms are agent, which is a learner like robot or programmer, and next one is environment, the word the agent operates in, and next one is state, the current situation, and the action, the decision or move made by the agent, and the last one is reward. It is nothing but the feedback. So goal is to learn a policy that maximizes the total reward over time. So examples are playing games like chess or go, and self-driving cars, robot navigation, which is nothing but the robotics. So common algorithm used are deep Q networks and Q learning. So in the next slide, which is nothing but the comparison table, or we can say quick recap, there are type, data used, goal, and example use case. So first one is supervised learning. As we know, it is a labeled data, and it is used for the predictions, email spam detection, and also house price prediction. They both are the real world examples. And unsupervised learning, which is nothing but the unlabeled data, and it is a pattern discovery or grouping, and it is examples is customer segmentation, and also recommendations like movie recommendation, and semi supervised learning, it is both labeled and unlabeled, which is efficient and cheaper learning. Examples is medical image analysis, and reinforcement learning, feedback based optimal decision making, and example games robotics. So next one is conclusion, which is nothing but to summarize. Machine learning adapts to data and improves over time. Choice of type depends on data availability and problem type, and the foundation for AI applications in every domain. As we know, supervised learning is the best when you have the past data with answers, and unsupervised learning helps to explore unknown structure or clusters, and semi supervised is a great when labeled data is limited. And last but not the least, reinforcement learning trains agent to learn from feedback over time. Thank you for watching this video.